if we draw a line, and at one end of the line we have the absolute destruction of them, and then the other end of the line we have the absolute of happy the absolute progression of them, right? Now our interface is going to do something here. I mean, I'm not sure what the probability of our interaction destroying their evolution. There's a reasonable argument that says we might actually kickstart it. We really don't know. We know microbes, bacteria, viruses are peculiar little things, right? They do weird things. They live in weird environments, and they do change. And so if we were going to try to figure out how we should interact with these, what we'd have to do is map out what the interactions would be, like actually think out what all the interactions might be, and then sample along the continuum, and then run. I mean, I could see designing an algorithm which has, maybe, I don't know, 20 or 30 entry points for different data sets, and then running multiple variations of this over and over and over again. And the Rand Corporation used to love to do this way back when, in the 60s or 70s. They would run these iterations and iterations of algorithms over and over and over again by changing just small components in the algorithms. Google does this as well, in order to try to figure out what's the optimal mix. And there's ways of doing this, but it takes a lot of work. Takes a lot of people, time, like mind time, where you're sitting down and figuring your way. A lot of whiteboards, and it's possible, but I mean, you have to come up with a way to look at it to make a better way of trying to understand things. And when you're dealing with policy, I don't know what else you could do. I mean, you could get experts in, and experts could tell you what they feel, but man, experts are so wrong. I'm writing an article called "The End of Expertise" that's going to be done by the end of September, and we did a study where we asked experts to predict what they thought the public was afraid of. We asked the public to predict what they thought the experts thought they were afraid of, and we asked the public to predict to tell us what they were afraid of, and we asked the experts to tell us what they were afraid of, and nothing matched. Right, nothing. And the scariest part of the world is it becomes more and more interdisciplinary, or choose the term, cross-disciplinary. Mm-hmm. You get this population of experts called marginal experts. They're sort of experts, but they're not experts. I mean, I studied nano for 15 years before I started talking about it, right? I mean, you've got to work at this to do it right. And what happens with the marginal experts is there's a whole bunch of research that's been connected that says those are the ones who think they're most expert when they're least expert, right? Mm-hmm. So the people who are giving all their opinions of what they think the future is going to be like and how we're going to interact with things in the future, I'm probably wrong. Probably wrong. I mean, and the fact that almost 50% of everything we've discovered about 20 to 25 years later is reversed or mitigated. That every time you try to do a study again after it's been done once, you never get the same significance level. I mean, you begin to wonder, right, that all these experts are making all these conclusions and they're wrong. So we probably need to come up with a new way of dealing with this. I mean, this is part of this NSA project I'm on. We're trying to figure out new ways of trying to get information which might be just a little bit more reliable. And so that requires a brand new way of calculating risk profiles. And that's why I think you're dealing with this microbial issue. We just don't have a risk profile for this at all. Mm-hmm. We just have nothing to compare this to. I mean, what are we going to compare it to? The introduction of smallpox in the Western United States when, in the 19th century, the white folk came over and gave smallpox to Native Americans who weren't prepared for it. Right? I can come up with hypotheticals, but there's not a lot of them, right? And again, they're all human-centric hypotheticals. And so it's a real problem.
Well, we certainly hope it's not like your example, because that would result in about 90% of our population going down the hole.
Yeah.
That would be pretty brutal. But that's also, one of the risks that, you're talking about is you're not just talking about the risk we're used to, we're talking about a risk that's so out of this world, if you'll forgive the pun, that it's difficult to even accommodate into a calculus, and that means it can be especially damaging because, you know, I mean, obviously the Native Americans were not prepared for smallpox, and that's the very death of it, you know.
I mean, there's other examples where we've done really incredibly stupid things. You know, I mean, I think I used the word proliferation when I talk. The mass proliferation of rabbit species in Australia was a good example, where we just brought in a few species thinking, "Hey, what the hell?" And now they're everywhere, or they're just taken over entirely. The ecosystem is getting crowded out. It's trying to figure out those things, right? Which we try to do in order to come up with new. This is the methods, and I mean, this is the methods and measurement issue, right? It's what method are we going to use to do this? Because the old methods for a human looking at a microbe, we spend most of our time destroying them, you know, and we'll nurture them along if it's going to benefit us in some way. But we don't really have much respect for something that's microbial.
Mm-hmm.
But I mean, we were once microbial. This is the big problem. The big problem is we're not prepared to extend this moral duty to a microbial species, even though we evolved from microbial species, which is a quandary, at least. And a sci-fi episode. It's always a possibility. You never know. You never know.
Kind of continuing on that, in terms of policy actors who kind of getting into something technical, and this might be, you know, if you feel like if you'd want to speak on this, you can. What do you think would be, you know, other than compiling this risk profile, how do you think like if you were leading the NASA expedition to Mars and this was you were in charge, you were the microbial risk guy, microbial risk consultant, how would you think that this could that even the beginnings of a risk assessment could realistically be compiled? Is this a theoretical endeavor, or is this something that we would need to be on the on the ground for? How do you think risk assessment should be or could be conducted in a policy space on this?
Well, I mean, I don't think we have to go to Mars in order to realize we're going to have a risk question. I think we can figure that out. Or we know a few things about at least the bacterial fossils that were found on Mars. That, you know, there's something that at one point was there, but we've learned a lot in I think biotechnology and genetic engineering. There's a lot of folks out there who are really primed and ready to deal with questions like this. I keep a lot of my colleagues, when we go to these big meetings talking about the morality of ethics of nano or genetically engineered machines, we get it. We get it. I mean, we know that we better come up with some better way of figuring out what it would be before we get there. It's just a hell of a challenge. That's the other problem. You've got to I hate the word co-invest. There's got to be, while we're preparing to go to Mars, we also have to be discussing the implications of going to Mars, right? I mean, they can't happen one after the other. That seems to be, we may never have the right answer, but hopefully when the expedition takes place, there'll be folks who have thought about it enough and have introduced enough of the right questions that we can ask it along the way. How best to react and how best to not act. I mean, I'm going to assume that our folks are going to be hermetically sealed in a zillion different ways. Mars is not a really nice planet. I mean, it's kind of nice looking at times, but I mean, from what I remembered out of my astronomy classes and planetary physics class, it's not the nicest place to hang. And so we'll try to isolate ourselves from the environment. And that, so we're also talking about our interaction with that environment may end up being those accidental releases, those non-intentional releases, where human microbes interact with alien microbes. And that could be real problematic. You know, I mean, without getting into a huge discussion of prions and viruses, and there's just a whole bunch of interesting ways bacteria and viruses interact with competing bacteria and viruses. You know, and I'm not sure we want to be the cause of all that.
Mm-hmm. Or want to deal with the consequences.
It'd be kind of weird to send people to Mars and realize that you can't bring them back. You know, I think that's something you have to think about, right? Because if there's a microbial infection that occurs and they can't really come back because we're not sure how they've been affected and the implications of them returning to their environment, that's a hell of a commitment for someone to make to engage in exploration if that's one of the price tags. You know, so it's a pretty broad issue. I mean, what I would do is like I've obviously been funded by the NSF quite a bit over the last few decades, and we talk a lot about investing in trying to understand the societal implications of what we do while we're doing it. Like let's invest in both. Let's not do stuff because we can do it. Let's let the scientists do what they're doing and simultaneously have folks who are social scientists like me and my colleagues who are following them very closely.
And have something of a division of labor.
Yeah. We dialogue a lot with a lot of folks and bring a lot of stuff to the discussion that a lot of them have never thought of before. Just kind of fun.
And I'm trying to think of, I apologize, I thought there was a question there.
You look like one of my graduate students right now. Sorry.
I feel like I was feeling more like a debater during cross-ex when they're at that 2:30 mark and they're just,
what happened? Yeah, I teach a risk communication class, and we just end up so many times at the end of this course just trying to figure out what's the right method to evaluate risk given data sets that are so incomplete, right? There's just no certainty to anything. The probabilities we're right are so low at times. I mean, you're just going, no serious statistician would take these findings, right? They just aren't significant enough. There's too many probabilities of error everywhere, but you got to come up with something, you know? And so you do all these wacky, and I mean wacky methods to generate data. And I've been involved with a lot of different studies that we had to come up with a method of generating data so we just would have it. And after it was over, I mean, we've come up with ways to fix our method, but I mean, it's just nonstop.
And when we generate data, when we kind of have the sum of the data to generate these risk profiles, do you believe that there is a moral obligation to act with significant caution when we're working with these kind of incomplete data sets? Like, does a data set need to be full and complete before we can make a call in a lot of the ways?
No, I think what we've been doing, hopefully this comes across. What we've been doing in the algorithms we've been building, for example, for genetically engineered machines, what we've been doing is looking at different sets of data that we can collect. And then for each of the sets of data, we are assigning an uncertainty value and weighing the set of data. So some sets of data weight more heavily than others because we're more certain of we're more certain of the data set. That's also calibrated depending on how important that data set is. I mean, if the data set's about extermination of all life on the planet, that's pretty damn important, right? If it's about, we might change the shades of the grass from deep green to medium green, that we're less concerned. And so it's a process of taking the data sets and moderating them by weighing them in certain ways. Mm-hmm. And you can design them and you can get provisional results when you do that. But I mean, you're right, because when you do the math out at the end, it's not multiplicative, it's like corroborative, that each of the sets might have a special relationship, so they corroborate a bit. And so you're not just getting like this is a 50% likelihood this is true, and 50% this is true, hence only a quarter, only 25% that both being true at once. There's an intimate relationship between these sets. I often tell the story about, when I'm talking to my students, about the probability of me using the F word is non-existent. The probability of me slapping my elbow on the table while I'm lecturing is non-existent. The probability of the two coming together is more significant than them happening separately. That's corroborative significance. And so when you do algorithms, what you end up setting is that these data sets aren't really independent. Mm-hmm. These data sets often bleed into each other. So if they bleed into each other and you can weight them based upon the level of uncertainty and weight them based upon how significant they might be as entire sets of data, you can put together something that will give you a value. And that value will at least be educative, right? I mean, and for policymakers, that's often all they get. You have to wonder, when Truman made a decision to bomb Japan, I mean, no one knew what was going to happen. There was all this predictions both ways, and they just had to make a decision. They had to educate themselves as best they could and made the best decision they could at the time. Mm-hmm. And I think that's what you're looking for.
That answers. That's a very good answer to the question. Just as an update, we can continue speaking, but we're reaching about an hour, so I wasn't sure if you had anything else on your plate. But I just wanted to give you notice that we were reaching about an hour.
I have nothing scheduled until about 25 minutes from now.
Okay.
It's another phone call, so
I'll have to try to find. Now I'm on the hook for 25 minutes of questions.
I think it's too bad you're not in Boston. In Boston, in the end of September, at the Sheridan and the Associated Auditorium, I think it's the Naval Auditorium. No, the Heinz Auditorium. They're going to have this wild event called the International Genetically Engineered Machine Competition. This is really wild. I went last year. We won our division, and it was a small division because there are not many people who do policy for like the folks at NC State and very few other places. And so what ended up happening is I'm going to be one of the judges this year. And this is high school, undergraduates, graduate students, and private research firms who bring their brand new discovered genetically engineered machines to the meeting. And I'm sort of the stick in the mud who's going to be asking them questions like, why is this such a good idea? Right? And it's going to be really, I think, instruction. It's going to be an education. It's people from all over the planet, right? They're from every continent, but Antarctica, but they're from every continent. They're from the major universities around the planet, and they're all bringing their little toys to this thing. And it's fascinating. It's just fascinating what these people are doing. They're taking E. coli, they're pulling out some of the gene sets, they're just replacing them with these bio bricks, which are these genetic cartridges, and they're taking an E. coli, which in and of itself is fairly innocuous, and turning it into, like, I don't know, a sensor, or turning it into a way to cure disease, or turning it into And it's like that robot competition we used to watch on television where people had robots beating up on each other. But this is the wet part of it. This is the genetic part of it. And they're the species people, right? These are the people making the new species. And it's really fascinating. And I'm waiting. I mean, the only reason I'm spending a whole week there is just I want to find out how they answer the questions. You know,
and whether those microbes can survive Boston winters, which is the real challenge.
I mean, I talked to some folks, Fred. I'm not going to give you too much information on this, but I talked to some folks from another country, not USA, who were experimenting with bugs. I won't tell you what type of bug, but they had done the experiment. They had changed gene sets and changed genetic behavior in order to make the bugs less pesty. So they were less of a pest. And they were doing it into an environment where they actually had released them.
Mm-hmm.
Like they just flew away into the ecosystem, right? I mean, they created a pest that never had evolved on the planet and then was released. And I was like, geez, weren't you concerned? You know, like the last thing you want is for something to go out there and start, producing a next generation of species, and not sure if it's going to crowd out the other generation or it's going to cause the problem to become even worse. There's a lot of people doing mosquito research right now that's just frightening. I mean, I understand it'd be a really good idea if mosquitoes weren't able to carry dengue fever, but I'm not quite sure that the best way to do this is to genetically re-engineer them and then release mosquito populations that have been genetically re-engineered into the environment. And it's the same big question. It's like, what happens when you change microbes or you change bacteria, or you produce a life form and turn it out on an ecosystem where it never existed before? And if we interact with microbes that are based on an alien ecosystem, I mean, who knows? Who knows? I mean, it could be its death knell. It could be, I don't know, it could make it, grow at astronomical rates. There's no telling what the implications of this could be. That's why you need those crazy ass folks in methods and measurement to come up with new algorithms to do the work on this. And they're not that expensive. They're just smart people with a lot of time who want to do this stuff.
And so you kind of mentioned there previously the environment that they would be working within. Do you think there's value in some respect also in disrupting that in some respect? That is to say, they, like for example, when we take drugs from the rainforest and we add them to our medical supply, ultimately you're changing something about our environment, our medical environment, but it's also assisting us. Do you think that the fact that we can perhaps even use these microbes from other planets might be not just something that we consider in terms of risks to the microorganisms, risks to us, but also benefits for us? And you think that that's
Sure.
a value to us? Do you think that's an ethical thing to do?
Oh, that's two questions. Would it be a value to us? Probably. Whether it's ethical or not is a whole other issue. But one of my other hats I wear is I'm on the Risk Communication Advisory Committee to the Food and Drug Administration, right? And so I look at these questions, and we know that the side effects of drugs are pretty significant. There's about 60 drugs that are out there that are so significant that they come with incredibly nasty warnings. And we reviewed them. And no drug it seems to be a freebie. Also, most of the drugs we've created don't work a lot. I mean, the drugs work, 20 to 40% success rate is really good, right? I mean, you sort of take a drug hoping it's going to work, but there's no drug designed for you. Mm-hmm. Sometime in the future, there will be a drug designed for you. right? We will know enough about your genome. We will know enough about what's wrong with you. We will know enough about how to take the drug and adjust its potency and its structure, its chirality, everything to work for you. We know that that's the possibility. Now that's great, but the question becomes whether our trip to Mars is going to be just an adventure in biopiracy or not. You know, and biopiracy is a weird thing because in this world, our planet, the biggest implication of biopiracy is that we go to other places and we find natural products, and then we derive chemical substances or compounds from them, which then go into drug medications, which we then sell back to the people who are from the same rainforest that we got the original natural plant from. That is an ethical question here, right? I mean, you know, take their stuff and then sell it back to them because it's better now. And I think that's where the ethics issue is. But the whole question about going to Mars in order to cultivate and then farm their microbes is. I can see. I mean, I know some really wild people in my job. I'm sure I could find people who would say that that might be a really good idea, but we have no idea what's there. I'm not sure we'd have to do that. Because the drug, for example, that we use for malaria, there's it's called artemisinin, I think it's called. It used to come from a plant. Now it's just produced chemically. We found ways to genetically induce the drug, so we could just make it. I'm not sure we need to farm out microbes for this. I think we can be really creative. I think that's what the genetically engineered folks are doing. You know, I'm not sure we want to go to Mars for this. Can it be helpful? Yeah. Yeah, I'm not, you know, I hope, yeah. I just, there's so many different probabilities. Probability we're going to interact with the microbes is going to be positive or negative. I just had this mental view of our initial explorers going there and sealed away in these little laboratories, much like the type of secure environments that labs use right now when they're doing research. Like if you do some really serious bio research and you're dealing with pathogens, you know, you're going to have a pretty secure lab environment to do that. I sort of see this type of relationship with folks heading off to not just Mars, but other colonies on other planets. That was that relationship is. I can't see us just interacting directly with the environment. You know, I don't think the probability that you could find a planet which has evolved and will be kind to the human species is really slim. Mm-hmm. I mean, it's I don't know what probability that would be. It would be pretty damn low. I haven't thought that one out. That would be a really big whiteboard. You'd have a lot of circles and squares on that board to try to figure out how the interactions would take place. But I think we're just going in a circle. I think we're getting back to our perspective of that you really need to have new ways of doing it, new methods. Mm-hmm. You can't just use the human-centric perspective on this. You know, human centrism has caused, like, I don't know. Human centrism justifies us taking nasty production facilities and shipping them over to Southeast Asia and producing products there and then shipping them back to the United States when they're finished, because those folks over there are a lot poorer than these folks here, and so we have to pay them a lot less to do it. It's the same thing. It's the same human centrism that just dominates this reasoning. That's just wrong. Strangely enough, I work with a guy who does rhetoric of plants. I'll have to ask him because he might have a different perspective on this. But he's looking at the sensitivity of non-human actors. You know. There was Bruno Latour is a famous writer, mm-hmm. who talks about agent network theory. He comes really close in his early writings to talk about that so many there are so many different actors in the decisions we make. And I think in his early years, he would have given microbes some rhetorical space, which would be cute, but I'm not sure how you would do that.
Mm-hmm.
But he's still around. You might write him. I think he's at Paris SciPo right now, so I'm sure he's out there. He's a little bit reticent to go back to his old theories, but yeah, I wonder if microbes should have a rhetorical space. It's a good question. You know, I'm not sure how many people in the debate community have discussed microbial rhetoric.
It would be, I would say it's a long time coming, but I've seen a lot of strange things happen. So, you know.
Yeah, I'm with you. Yeah, over a few decades of debate, boy, the world just changed radically. So I'm not sure where else to go on that. But I'm a big, obviously, you know, at this point in my life, I'm working on is bizarre methods. That's what I do. I'm the social science editor to the Journal of Nanoparticle Research. I sit around and figure out whether the methods make sense or not. So, it's where your career sometimes goes, where you're not in total control. You're in economics, you wait.
Yeah, well, I'll just be bossed around by math majors for the rest of my life.
They always do that. Don't worry about it. Don't worry about it.
That's how they go.
Yeah.
Well, I fear I don't have too much more to talk about. You've given a fantastic interview, by the way. Thank you. It is both engaging and informative. So I think I'm getting it to about the end of what I have, and it's good because it sounds like we came full circle. But absolutely. So do you have anything you would think of adding kind of summatively, or anything you felt like you wanted to explore more in this discussion?
I think we covered it all. I think my perspective of coming up with a new way of doing this type of thinking needs to take place. It can't be human-centric. It has to be something else. I'm a big advocate of algorithms, so I think if I was teaching my graduate class an algorithm, this is a really good subject to put on the whiteboard.
Mm-hmm.
You know, because even though we may not be able to collect all the data to put in all of sets of brackets of variables that might be relevant, just trying to figure out what they might be is often entertaining. You know, and it's probably due. I think we realized after with emerging science, because it really went from biotechnology to nanotechnology to synthetic biology to this. These emerging sciences and technologies are teaching us we're just not close to being ready. We're so used to figuring out, you know, we look at products, we look at the probability that people will interact with the products, and then we look at how dangerous the products are. We do a mathematical calculation. And that's okay when you're dealing with stuff when you're dealing with things you know about. But when you're dealing with incredibly high levels of uncertainty, that just doesn't work. That math is just ridiculous. You know, I mean, everything is just ranges of probabilities against ranges of probabilities. And boy, that math is complicated. You know that. Your economics major. It gets really complicated when you have range of probability. Because they don't sum well together. Mm-hmm. That's probably, if I was involved with not that I'm going to be doing it, I just signed on to a decade of research in nanoscience. So I think if I was going to do something like that, I would probably, if I was going to be funding, I would fund folks to try to figure out how to be able to evaluate things like microbes and bacteria in ways that are not human-centric. And then I'd really like to figure out if they do deserve a voice or not. If there's a rhetorical place for them or not. Because I'm not sure people have talked about that. We've talked about it with endangered species for a brief period of time. whether they deserved a rhetorical space or not. But I don't think people have got to the microbial and bacterial levels yet, which is always fun.
And I mean, while we don't give much of concern to, except in considering harmful risks to the microbes in our own environment, is an interesting part of opening that rhetorical space for microbes to think about vastly different kinds of life, or vastly differently constructed life.
Well, I mean, if we had a few hours, we could sit down and generate a list of the top 10 worst experiences in history coming from using human-centric values to try to understand new things. And it wouldn't take long to put that list together. And then from that list alone, you would make a pretty damn powerful case that maybe we need to do something else. Yeah.
Well, I think that's a fantastic kind of summation of what we're talking about. And again, thank you very much for deciding to be interviewed as part of the NASA debate interview series. We will be using your interview as research when we're making arguments on this. And then just thank you for all your help.
No problem.
And this has been a very engaging discussion, and I hope I interviewed you as well as this topic serves.
Sounds like fun. Good luck with your debating season, and give Paul a big hug for me.
He's not a huggy kind of guy, but
I've been to his wedding. I mean, I've known this guy for a long time. All right, take care, buddy.
Thank you.
Bye
You too.
bye.